Sir, Akash sir.
Yeah.
Shall we start, sir?
Okay, fine.
Okay,
I am
sir.
ready.
Okay, sir. Thanks.
Good morning to all. Today we are all gathered here for AICTE sponsored 6 days online STTP on emerging trends and research challenges in next generation wireless networks. The pleasant morning. I welcome you all for this online STTP program day 4 session 1. So today's we have great resource person Dr. G. Prakash sir, Assistant Professor Senior Grade Department of CSE, Amrita School of Engineering, Karnataka. So before we are getting into the session, let me have a short intro about today's resource person. For that, I call Ms. Grija. Let me have a profile.
Yes, sir. Pleasant morning to everyone present here. You invoke a new future when you envision your past in the light of your present. Before going to the session, let us see a short intro about our today's resource person, Dr. G. Prakash, Assistant Professor, Senior Grade, School of Engineering, Bangalore, Karnataka. He completed his undergraduate degree under the Department of CSE from Adiyaman College of Engineering, Madras University, an MBA from Bharathidasan University. He completed his postgraduate degree from Annamalai University and doctorate in network security from Anna University. His area of specializations are network security and software testing. He was designated as editor for special issue of International Conference on Intelligent Computing published in Scopus Index Journal, a journal of competition and theoretical nanoscience. He is having 23 years of experience, and under his guidance, 5 scholars are doing PhD. He published more than 10 journals and presented various papers in national and international conference. Also, he acted as a chairperson and delivered lectures on conferences, seminars, workshops, and so on. I hope you will have a great session this morning. So kindly I welcome Dr. G. Prakash to share his thoughts with us on the topic of demystifying security threats and countermeasures in radio access networks. Please, sir.
Yeah, thank you for the nice introduction. Uh, so, so good morning, one and all present here. Today, I am going to discuss about the security threats and vulnerabilities in the wireless network. Okay, so I'll be sharing my screen. Whether everyone can see the PowerPoint slides?
Yes, sir.
Yeah, fine. So I'll be put in the slideshow mode. Okay, fine. So today's topic is demystifying the security threats and countermeasures in radio access network. Shortly, we are calling as RAN. So everyone speaks about the various generation of networks, starting from 1G, 2G, 3G, 4G, and now we are in the era of 5G, fifth generation networks, and we are also moving to the sixth generation too. Okay, so as we are just getting the technology being advanced to the fifth generation, on the other end there are many kind of threats and vulnerabilities happening in and around these networks. So even if you are talking about the technology that has been advancing towards progress, parallelly the threats are also keeping in advanced. So we have to understand about these threats and countermeasures while we are just working with this kind of technologies. So that is what I just had mentioned the title as demystifying. Demystifying means what? Just to make you understand about what are all the threats and countermeasures that are available in the RAN. So again, I am not focusing on the general fifth generation or fourth generation networks. I'm just narrowing down the topic to especially the radio access network. So this is where we are having the particular data that has been transferred between the various networks in the form of radio waves. So while the data has been transmitted through the radio waves, so what is happening? So what kind of threat and how this kind of threats are happening in between, that kind of knowledge we have to know. So and that's the topic what we are going to discuss under the wireless networks. So as this particular STTP focus on the wireless networks, so I'm just inclining towards this security threats and vulnerabilities so that everyone can understand that part too. Okay, so my name is G Prakash and I'm working as assistant professor selection grade. Sorry, I am not senior grade, I am selection grade. Okay, so and I'm working for Amrita Viswavidyabidam Bangalore campus. So with this, I'm just showing some image to you. So what actually this image represents? Shall anyone tell me? My dear friends, I think everyone are faculties of electronics and communication engineering. So I think you may be knowing this kind of details. Okay. So what exactly this represents? Shall anyone interact or through say the chat? So I think if you are muted means you shall send it through chat also. What exactly this image has been representing? At the first thought, what you are getting into it, you can just put it in chat box also. Okay, so otherwise if you can unmute and answer, please tell me what exactly this image represents. So there are around 40 participants. I would like to interact with almost everyone. But anyway, due to some time, it will be better if someone shall interact with me. Okay, communication towers for cellular networks from Abdul Rahman. Yes, very good. Thank you. So now you can see immediately about this particular device, or you can represent it as a cellular network generally, and also it is used for communication purpose, and this is where we are having in almost in all our cities, and we could able to understand immediately what it has been showing to us. But on the other end, whether these devices are all secure, so that is the big question what we are having in our mind. Okay, so let us move on. Let us see how the growth of the next generation networks is happening. Also parallelly how the security risks are happening in the particular next generation networks. It all started with the 1980s 1G network, where we had used only the analog device. So at the time we are using the normal landline phone, okay, for communicating the data, and all this data are analog. So slowly we move on to the 2G. So now our data has been, our voice has been transferred digitally. Okay, so that what happens, the noises which has been happening, which has been communicating along with our voice signal, has been substantially reduced, so that we could able to increase our voice capacity. This is the second generation network during the 1990s. And then to some extent we are also in the third generation. Okay, so just before using this smartphone, what we are currently having, we are in the third generation only, as everyone knows. So that particular technology has been moving to the mobile phone. What technology I am talking about? The internet. So if we are using the internet, as of now we could able to access through our mobile phone itself, but some 20 years back it was not like that. Okay, so that was the third generation, where we are slowly moving on to the mobile internet, and also the smartphones came into limelight. Okay, after that, now at present situation, okay, so we are in the fourth generation. So but this fourth generation has been evolved right from to 2010. Okay, so even though now we are in this particular period, so it actually evolves from 2010 only, 2010, and there we had the particular long-term evolution. Okay, so that is the kind of technology even if you are using your mobile way how we can understand about this particular particular fourth generation. Okay, where we are having the LTE. So whether I'm audible, sorry, because in between some phone call I'm using my mobile data. Again I'm talking about the network only. Is it audible?
Yes, sir, it is audible.
Okay, fine, fine. So here, what is the part is we are in the fourth generation, and we could able to access the video, okay, and audio data frequently. So in third generation, it was not like that. So now the due to the long term evolution, we could able to accurately just upload and download the videos and audios quickly because of the particular bandwidth, network bandwidth, and the other facilities what we are having now. So this is the fourth generation network, and also to some extent we are in the fifth generation also. Even though it is not entirely coming to our country at present, but in another few months we are moving on to the fifth generation where we are going to have the massive broadband. So previously, some 20 years back, if you want to get a internet connection for your office or for your home, that is very difficult. And even though if you are getting the connection, you could not able to access the internet very quickly and fastly. So this is the problem what we faced, and in the fourth generation, to some extent, these problems has been solved. Okay, we could able to get the home network with all the facilities like bandwidth facilities and the downloading and uploading links. Everything is possible, and that even though it is possible, to some extent we are having some kind of problems also in terms of some kind of latency that also existed. But if you are thinking about the fifth generation, we need not want to worry about the delay at all. Okay, so we are having the massive broadband. Okay, ultra HD, it is not HCA, sorry, it is ultra HD. Okay, high definition, ultra low latency. So this is another important point. Ultra low latency is the most important characteristics of the fifth generation network. And also the network slicing. So the details about the network slicing will be shared by another expert, okay, probably under the SDN. So here, as a overall, you can see how the growth has been evolved from the first generation to the fifth generation. So this is the way how we can understand this point. But on the other end, we can see the security vulnerabilities also. Okay, so again, if you are coming to 1G, okay, we are not having security at all. We could not able to think about the privacy. So during the 1980s, so there is no understanding about the security. Coming to 2G, somehow we got into the terms of security like confidentiality service or authentication service. We heard about the terms, but again we are not having that much capability to protect our data. Okay, so this was happened during the 2G. So that means we are having some kind of authentication, but it is one way. Okay, one way authentication means what? We can able to just provide the username and password from our side, but we are not sure that whether this particular data which we are transferring with that authentication capability is secure. Okay, to the maximum extent. So that we cannot assure. That kind of guarantee we are not having. So this was the situation in 2G networks. Coming to the third generation, we had made use of the internet enormously. Okay, so right from 2000 until now, even though we are just using the web application, now all this web application has been transferred to the mobile apps. But during the starting period of 2000 until just 2015, So we are just inclined towards the web applications, and because of that, what happens? Some kind of security threat related to the IP traffic and related to the particular encryption key issues. Even though we are having the security measures in terms of some providing some encryption algorithm, some kind of certificates, okay, digital certificates or authenticating certificates, still we are having the vulnerabilities that has been faced. So this is what the period of third generation. There we are trying to protect our data through the web. Okay, so we are using majorly the web applications. So how to protect our web applications from the external attacks? Okay, so for that we have to think about all other kind of measures, but still it is not completely solvable. Then coming to the fourth generation, now we had moved from the web applications. That's what I told you. So until 2015, even now we are using web, but mostly we had just used all our particular normal day-to-day operations through our web application. Now everything has been coming in into the mobile phone as a app. So now what happens? We are in the fourth generation, and now we are using mobile applications. So the accordingly what happens? The threat also has been transferred from the IP traffic to the MAC layer. So IP traffic in the sense means I am talking about the internet protocol. So in the internet protocol, we are just moving along with various data through the web. So that what happens? The traffic congestion occurs and the traffic is monitored by the attackers. Okay. So that is what we are calling as eavesdropping. Eavesdropping is a kind of attack where the particular attackers will continuously monitor the traffic even though it was not disturbed, it was not modified. So that details we could not able to track, because silently if one particular attacker is just watching the traffic, means how could we know that there is a kind of attack happening in the network, in the public network? So this is the problem what we faced in the third generation, that has been continuously present in the fourth generation also, but it has been shifted to mobile. So now what happens? We are using new type of devices. So now the threat has been just spreaded to the MAC layer. So initially it was in the network layer. Now it has been coming into the physical layer also. Okay, so now the threat using the particular attack, the attackers could able to understand our physical MAC address, medium access control layer. So if the this physical MAC address is known only to a mobile phone or to the laptop which we are using, but if these particular addresses are known, then what is the use? Your entire system has been hacked. Okay, so this is the kind of attacks what we are having in the fourth generation. Coming to the fifth generation, what we are now in this era, we had moved the technology from mobile to IoT, so Internet of Things, and we are also thinking about the smart cities, virtual reality, augmented reality, all such kind of advanced techniques are now present. Now again the threat has been also advancing. So vulnerabilities are now spreading towards where? To the software defined networks. So what is software defined networks? So just to give an introduction, so whatever the particular traffic, the data which has been transmitted from our laptop or mobile phone to the outside public network, it has been controlled by the hardware devices like routers, switches, repeaters and all. So these are all the hardware components what we are making use to control the entire public network. So instead of controlling through hardware, if you are thinking about the particular software to control all these operations, so there comes the software defined networks, that will be explained by another expert probably in the today's afternoon or tomorrow, like that. Okay, I don't know. Okay, fine. So here this threat has been just spreading into SDN as well as NFV. NFV is nothing but the network function virtualization. So that means what? The entire network function what is happening in the public and private network is virtualized. Okay, now we are using the VMware technologies, as you know. Okay, so now I am having a laptop with my Windows operating system that has been physically installed. Now in this system, in this particular laptop, I can able to virtually install some other operating system also, and I can work with these two operating systems externally. In the physically, I can work with some applications, and virtually I can work with some other application also. For example, virtually I can just install Ubuntu or Linux, and there I can able to do some other tasks. So this kind of virtualization has been evolved into the network functionalities also. So accordingly, even though the technology is like we are using SDN or NFV, the vulnerabilities are also just spreading towards this kind of devices. So that means what you can understand as a whole, whatever technology we are keeping on increasing on each and every phase, parallelly the attacks are also keeping on increasing and advancing, so enhancing. Okay, so the attacks has been enhancing means what, the attackers are also that much knowledgeable, they are smart enough, they can able to just learn all this kind of technologies quickly, and they can see the way how they can attack the system and create some kind of vulnerabilities or threats. Okay, so this is what the problem what we have to think about. And slowly after 10 years we are moving to the sixth generation, but we are not into it. It was still in the developing stage only, and it was just being developed in some other countries, but it is not incorporated commercially. But you shall think about the security that can be combined with the artificial intelligence or autonomous systems. And also we can think about some kind of wireless brain computer interactions. So these are all the other advanced technologies which is going to happen in 2030. And also we can see the multi-sensory XR. Everyone hears about the virtual reality, augmented reality, and here XR is the extended reality. Extended reality in the sense means what? See, now I am just speaking to you and you are hearing my voice. So through my voice, you are just trying to understand what I am talking about. Okay, so this is one kind of sensing. So similarly, what you are doing, most of you, I know, all the participants, you may be hearing me. Parallelly, you may be looking into WhatsApp. Otherwise, you may be just parallelly opening some browser, and you will be working with some kind of other academic activities or something else. Okay, so that is also done. See what happened at one thing, at once one particular work is you are hearing my voice, so which you are sensing my voice, sensing through your ear. On the other end, you are just working with your system, there you are just visualizing. So visualizing means what? Visualizing through your eyes, and then you are using your hands, okay, and touching the keyboards or the mobile phones touch screen and doing some kind of actions. So now what happens, you are doing the operation of touching the device. There the particular sensory organ is your hand. So you are just doing this activity parallel. So just think about the same scenario that can be extended to the virtual reality or augmented reality. So that's what we are calling as extended reality. So these are all going to happen, okay, in the sixth generation. So how all parallelly you can do all the three operations virtually? Is it possible? But there also we can consider the some of the security attacks which is going to happen in future. We cannot able to avoid it. Okay, so this kind of security issues has been present in almost in all the stages. Okay, so from this point of view we can finally say one important task is, or an important term is, there is no absolute security. We cannot provide it, so that is not at all possible. 100% security is not achievable. Okay, so with this kind of knowledge of this, we can see, we can just move on to our topic, narrow down our topic to the RAN, radio access networks. So if you are just looking into the mobile telecommunication networks, which consist of 4 domains. Okay, you can see from this diagram. Okay, the 4 domains are like we are having the user equipment, that is our mobile phone or laptop or something else, and we are having the radio access network, shortly RAN, and we are having another particular domain called as core network. Okay, and we are having the fourth domain which we are calling as the transport network. So the particular smartphone or the router which we are using as a device is called as UE, and the RAN is what we are going to discuss, which uses the radio frequencies to provide wireless connectivity to the devices. Okay, so we are just making use of this particular RAN, and that is what initially I had shown in the particular diagram. Okay, this diagram is exactly we are calling as cellular network. Okay, so but additionally we shall just represent technically as radio access network. Okay, that is what we are talking here, because this uses the radio frequencies to provide wireless connectivity to our devices, our mobile phones or smartphones or laptops. How we are just getting all the data from the radio waves to the digital waves. So this kind of RAN will provide this facility. That is one domain. The next is the core network, where we are having the coordination between different parts of the access network. See, I told you the RAN is the communicating device between your user equipment and the core network. We can see from the cellular network architecture diagram. So in this, if you are looking into the core network, there are various networks that has been integrated into this. Okay, so today in the fifth generation 5G networks, we are calling this a core network as evolved packet core. Okay, shortly we are calling as EPC. And in this core network only, we are having many kind of additional networks like packet switching, circuit switching, and even IP multimedia. All this has been just integrated, has been consolidated and put inside the core network. Okay, so that means what? It will provide coordination between various parts of the access network. So suppose one particular network is using packet switching, in another location it is circuit switching, in some other location it is some kind of multimedia domain. So all this has been coordinated in the core network, and also it provides connectivity to the internet, so that we can see out it is connecting to both internet as well as the public switched telephone network. Okay, so finally we are having the last domain, that is the transport network, which actually provides connectivity between the RAN and the core network. So here you can see from the diagram, RAN is connected to the core network through the transport network. Okay, so there are such four domains which we can look into here, but we are not going to discuss all these domains exactly. We are just focusing towards only the RAN, radio access network. So radio access network is not just antennas. That's what I told you. We should not say it is just an antenna or a cellular tower. Instead, you have to say it as a radio access network, and it consists of the three components. I think this stuff many of you are aware already, because I am basically a computer science people and working for the security domain. So that for me it is all new. Okay, so anyway, I'll be just giving some basic introduction. So here we are using the first component is the baseband. So baseband is what we can say that computer intensive signal processing functions which makes wireless communications possible. So that means if I want to just communicate from my mobile phone, all these particular signals, I cannot assure that it is purely digital. So many kind of signals has been available, especially we are using the radio waves as a whole, we can say like that. But these radio signals has to be just modulated, has to be transferred into the computer intensive functionality. Okay, that means it should be just processed in our computer. Is it possible like that? So there comes the baseband. Okay, so that will make the particular signals to be processed in terms of computation. That means computationally you can process this kind of signals using this baseband as one of the component. And so that's what it is having various functionalities like signal processing for using multiple antennas, signal processing for detecting and correcting the errors, and also signal processing to ensure that wireless transmission is secure. So this baseband is having the responsibility of various kinds of signal processing functionalities. And one such functionality is what, that wireless transmission that is going to happen in the network should be secure. So that also should be taken care by the baseband. And also it will manage the wireless resources effectively between various devices in the network. So this is one particular component of the RAN which we have to think about. Then comes the next particular component, radio. So here radio converts the digital information into signals that can be transmitted wireless. So this digital information has to be communicated in the uh, general outside externally. So how we are communicating externally, this digital signals has to be digital information has to be transferred into the signals. Okay, so that means radio waves. So then only it can able to just transmit in a particular bandwidth. Okay, so in the right frequency band and at the right power levels. So this kind of details are also supported by RAN. Then coming to the third component is antenna. So antenna just radiate the electrical signals into radio waves. So generally we are saying this cellular network as antenna, but actually the RAN consists of these three components. It is not only the antenna, it is also having this baseband and radio which we have to consider. Okay, now what is this RAN exactly? It is actually a network. Okay, so it is actually a network infrastructure which is used for the mobile networks, and in this we are having the radio base stations with large antennas. Okay, so that is what we are calling as a cellular tower. So what it will do, it will just connect this user equipment. All our mobile phones to the core network has been connected only through the RAN, that you can see from the diagram again. And these base stations which is present in the as a cellular tower or something else. Okay, so is primarily connected via the fiber backhaul to the core network. So that means we have to connect these transceivers, okay, of this RAN to the core network. So for this we are using some kind of fiber backhaul. Backhaul is nothing but the entire network which can store high bandwidth, high speed capability device. Okay, so we are just mentioning it as a high speed network. Okay, generally we shall call it as high speed network, and this has been used for connecting this RAN, okay, that is the base stations, with the core network. Now what this core network will do is, it will just include the servicing subscriber request. See, I am having my mobile phone, I have to connect with some particular person, means I have to just purchase some subscriber network. So that is what I am using, Airtel or Jio or something else. Okay, now just I am calling one of my friend, means, or sending some message to some other person, means my user equipment, what it will do, it will just simply transfer it to the RAN, radio access network, and radio access network will transfer the same information to the core network, and there only the subscribers will request for such kind of data transmission with the other networks, with the other cooperating networks. Okay, so this is happening in the core network. So all the responsibilities will be now taken care by the subscribers. Okay, they only route the traffic, route the data to the respective domain or respective network, and they will transfer it to the internet, or also they will transfer it to the PSTN. Okay, so that all the particular request made by the user equipment has been taken care by the subscriber at this point, that is in the core network. Okay, so that means what you can understand, this core network takes the major responsibility. And also we are using the cell phones. Means our mobile phones uses the radio waves to communicate by converting voice. So this is what normally we are talking about. Okay, so we are just having our analog voice which has been converted into digital signal, and that has been transferred to the network. This is normally happening. Okay, now suppose if I want to connect to the internet from my mobile phone, I have to first connect through the RAN only. So it is not directly going to a particular core network, or it is not going to the particular internet directly. So it is actually routing through this RAN. So that is the role of the RAN which we have to think. Okay, RAN will take care of all this kind of operations. So just like that, it is not directly transferring to the internet from my mobile phone. So that is the way how this particular architecture has been shown. And today's RAN is can support MIMO. MIMO means what? Multiple input, multiple output antennas. So that means what? If the data is huge enough, the data can be just taken care by many antennas or many RANs. Okay, so parallelly they can able to take the same data in the same path. So that what happens? The data will be transferred very quickly. Okay, so that's what we can say. We are having the wide spectrum bandwidth, and we are also having the multi-band carrier aggregation. So all these features are present in the today's RAN. Okay, so that is one thing what we have to consider with respect to 5G. Now coming to the RAN components, as I already mentioned, we are having the base station, we are having the antennas, and we are having the core network. And today's core network includes the RAN controller also. Okay, and in modern LTE network, as I mentioned, today's network is having this long-term evolution, and EPC is required at the core. So that is evolved packet core. Okay, so this is what we are talking about now in the present scenario. And what is this evolved packet core? So it is a flat all IP based core network that can be accessed through the 3GPP. 3GPP means third generation partnership project. It is a forum. So this forum will make every kind of wireless networks and terms concepts to be standard. Okay, so whatever we are having a new technology, that has to be standardized, and that standardization will be provided by the third generation partnership project forum. Okay, so accordingly now today's technology, the fifth generation is using the LTE networks, where we are having the core network as evolved packet core, and this is nothing but a flat all IP based core network. Okay, so initially we had packet switching or circuit switching, as we had seen in the previous slide, but today everything is based on IP. Okay, so that is what we are talking about, the evolved packet core. And sometimes it may be used in the non 3GPP also. So it can be accessed through the non 3GPP radio access like WiMAX or wireless LAN. Okay, but allowing the handover procedures within and between the both radio access types. Even though we are making use of the non-standardized, we can able to just hand over the particular network functionalities between both standard as well as non-standard. That means between both 3GPP and as well as non-3GPP. So why we are talking about this handover procedure means, for example, let me just commercially tell for those who are not technically understanding. Suppose you are using your college net, college wireless network. Okay, so now what happens? College network is slow, little bit slow. So you want to access some kind of video data. So what you are doing from your mobile phone, you are just switching from college network, wireless network, Wi-Fi to the mobile data. So now what is happening here? Okay, so you are just doing the handover procedure. So that particular wireless Wi-Fi network is handing over all its operation to the mobile data. So here the mobile data is what the particular subscriber what you are connected with. Either it may be Airtel or Jio. So during this handover procedure, okay, we may face with some kind of threat and vulnerability. The attackers will monitor that too also. That short duration, that short timings is enough for them to penetrate some kind of malicious code. Because you just imagine, if you are using your college network, definitely they will be providing some user login credentials. Okay, so from there you are moving to your mobile data, either it may be Airtel or Jio. Okay, so at that time, that particular security measures or security controls has been stopped for some extent, some time. So that means what? At that period, during that handover procedure, the particular attacker could able to inject some kind of attack, and they can enter into the network. Okay, so this is the problem what normally we are facing. Even though this duration is very short, handover procedure is very short. Okay, so these are all the things what we have to look into carefully. Now coming to the various examples of the RAN types, we are having GRAN, which is the GSM, that is Global System for Mobile Communication Radio Access Network. That is some thing older RAN type. And coming to GRAN, okay, GRAN is especially the same as the GRAN, but we are having the inclusion of edge packet radio services. Okay, so edge means, so I have added this terminology here. You can see these terminologies. Okay, edge represents the enhanced data rates for global evolution. Okay, so for data rates, we are using this particular edge facility. So edge will enhance the data rates. So that kind of services has been added in the GRAN. So then now it is called as GRAN. This is another type. And third is UTRAN. So UTRAN is the UMTS radio access network. Okay, Universal Mobile Telecommunication Service Radio Access Network. So this is what we are currently using in our particular cellular towers. Okay, and also we are having this EUTRAN. So this is the long-term evolution UTRAN with high speed and low latency. So this is the latest RAN, and all the recent installation of this particular network is present with the most of the cellular towers. Because once if EUTRAN has been just installed, then only we can move on to the 5th generation, and that is the idea behind that. Okay, so these are some of the RAN types. So let us have a quick walkthrough over this 2G, 3G, 4G RANs. Okay, so starting with the 2G architecture, that basic architecture, we are having the structure like this. You can see the OSS, which is the operating and support subsystem, and we are having the core network, and we are having a couple of interfaces like A, B, C and all. Okay, so see, you can see this kind of interfaces. These interfaces are called as AR interfaces. These AR interfaces are present in the 3GPP, third generation partnership project, where we can able to understand about the functionality of this. Okay, so otherwise we shall see some of the interfaces, not all, in the respective 2G and 3G and 4G. So in 2G we are using ABIS and UM interface. So this radio interface standard, so these interfaces are all called as AR interface or also radio interface. Okay, so they are used for some purpose. Here UM interface can be used for exchanging the data between the mobile equipment or the mobile device and the base station. So that is the BTS. Okay, and ABIS interface is used for linking between this BTS and BSC. Okay, that is the base station control. And here, as I told you, we are both using the standardized and non-standardized architecture or network. So this is not been totally standardized. Okay, so that is what we have to think about this ABIS interface. So if it is not standardized means we cannot able to assure about the security. Okay, so the ABIS interface allows control of the radio equipment and radio frequency allocation in the BTS. So I want to control my radio equipment, and also I have to allocate the frequency band for the radio waves. So all this will be taken care by the ABs. And next is the A interface. So A interface is what exactly we are connecting between the core network and the base station, base substation. Okay, so we can enable the channels, time slots. That means the actual communication between the mobile system with that of the core network has been happening only through this A interface. Okay, so this is what we can understand from the 2G GSM RAN architecture. Coming to the 3G UTRAN architecture, again we are having the same kind of setup like operating and support subsystem or the base station controller, but we are calling this as RNC. Okay, so RNC is what? Radio access network controller. Okay, so this RNC facility is not available with the 2G, which has been present with the 3G. And here also we are having some kind of interfaces like LU, LUB, LUR, UU, and many such kind of interfaces. These interfaces are all helpful to communicate between this kind of transceiver, core network, user equipment, and so on. Okay, so this is what we have to understand. Okay, and coming to the latest 4G, what we are currently using, this UTRAN architecture. Again, we are having the operation and support subsystem along with the core network. So we are having the user equipment. So far, whatever we had studied in the 2G and 3G, we are having the user equipment or the mobile station that has been connected, okay, to the core network singly. Singly in the sense means what? Serially. So now parallelly we can have some kind of multiple substations, okay, or multiple base stations. Okay, so that's what earlier I told you about MIMO, sorry, multiple input, multiple output. So if I am using this multiple base stations, obviously what will happen? I can get more speed and the fast network. Okay, so that is what happening here in the 4G. So this will have more complex air interface mechanisms, as I mentioned, such as advanced multiple input, multiple output, and also we are having the coordinated multi-point cooperation. So here we are having a specialized base station transceiver called as E node B. Okay, so this E node B has been in multiple numbers, as I mentioned, MIMO mechanism is there, support is there. So what we are having is we could able to think about the data flow diversely. Okay, that means we can move the data from one RAN to another network, and we can able to do the task very quickly. So the carrier aggregation and dual connectivity are all possible in this 4G. So simply what we can say in commercial terms, again you are taking your mobile phone. Now you are using two SIMs. Okay, so both SIM cards are different. One is Airtel and another one is Jio. Both are having the internet facility. Okay, you can connect with the internet through the mobile data. Suppose I want to just switch over between one particular network to another network, that is possible within my mobile phone between two different subscribers. Okay, so that you can just connect it with this kind of activity, because for Airtel we are having a separate base station and for Jio we are having a separate base station transceiver, but we can able to transfer between. Okay, and also we shall able to transfer with the core network and the user equipment using the respective interfaces. And even Airtel can able to connect with Jio and Jio can connect with some other network. That is also possible between the two different base stations. Also we can connect. So for that we are using a specialized interface called as X2 interface. Okay, so this will help you exactly where means in many electronic devices other than your laptop. Okay, so already you are aware that your mobile can be connected through internet. So now nowadays we are talking about the IoT, Internet of Things. So using IoT, what is the scenario is the IoT may be having various devices, like even our home can be connected with various network, various internet based home. So how it is automated? Our fan, refrigerator, washing machine, TV, okay, microwave oven, all this can be interconnected through the network, even though they are separate devices. They are not only the electronic devices or a digital device. They are also electrical device. Okay, now you can see there is a setup where we can able to connect with this all the devices through the internet. So this facility, how it is possible? Because of this 4G e-uteron. So I want to just make use of my Airtel subscriber, okay, to connect with the particular electrical or electronic devices. I want to connect with any IoT device. So how it can be done? How it is possible? Yeah, this is the service what we are having. This is the architecture what we are having. Okay, so this is what we have to understand about this 4G, where we can make use of the IoT services possible. So and also IoT devices are lightweight devices where we can also provide ultra reliable low latency communication. Okay, so the latency is very low, and because of that we can able to make use of this 4G e-uteron in many lightweight devices, especially the IoT. Okay, so this is what we have to consider with respect to the 4G e-uteron architecture. So now you can just have the traditional architecture. Normally what we are having is the user equipment, which is called UE, baseband unit is BBU, and we are having the base station, and we are having the CPR. Okay, so and we are having all this particular base station which can be connected through a fiber backhaul. Backhaul is the particular core network. Okay, so which can be just used for transferring high speed data or high end data or high bandwidth capability it can able to accommodate. So this is what we are talking about, the connectivity between the two different RANs, okay, through the core network using some backhaul operations, using some common public radio interface. So this is the basic structure what we can able to define. Okay, if the same architecture has been extended, like if you are splitting this BBU, that is the baseband unit, into distributed unit and the central unit, okay, and if you are including the cloud, okay, cloud technology in the RAN, then we are calling it as a 5G RAN. Okay, so why we have to see this traditional RAN architecture means we have to understand where we are just actually working with the 5G. So in 5G means we are just making use of the 5G cloud based RAN. Okay, so this 5G cloud based RAN will have additional particular component like distribution unit and the central unit. So one is for centrally controlling or transferring the data, another one is distributed, because basically the cloud itself is a distributed computing. So what we are having, we are just distributing our services across the networks through the cloud. So that we are calling it as the 5G RAN. Okay, so otherwise if you are not using the cloud means it is the normal traditional RAN architecture what we are having. Okay, right. Now let us see what are all the limitations, okay, of this 2G and 3G generally. So then only you can see, understand why we are going for this 5G RAN. So I am not talking about the networks generally, 2G network or 3G network or 4G like that. I am talking about the RAN, okay, limitations of the radio access network, and why we are going for the 5G RAN. So coming to this 2G RAN, we are having the functional architecture which is fixed, and it is geographically localized. So that means what? It is difficult to just shift from one location to another location. Okay, so and this backhaul operations to and from the radio sites was not time critical. Okay, so not time critical means what? There is no specific situation if you are handing over the procedures from one network to another network. So what is the time it will take to do the handover, and whether it is possible or not, that we don't know. So that is not time critical, and it is based on the user scenarios and traffic. Otherwise, simply we can say it is difficult. Okay, so handover procedure is not possible from one subscriber to another subscriber, or one network to another network in 2G RAN. Coming to 3G UTRAN, comparatively it is better than 2G, but it is also having the latency still. Okay, so again the latency will occur for this handover procedures. Okay, so handover should take within fraction of seconds. If it is taking more time, means what happens? The attacker could enter into the network using the hole, using the gap. And here another problem is resource allocation could not respond to radio and traffic conditions. Okay, so the resource allocation is not effective. Okay, so this is the problem what we are facing with the 3G UTRAN. So in order to overcome this, so now we are considering this 5G RAN, which is the next generation RAN, and it is believed to be a true worldwide wireless web. Okay, so everyone heard about the World Wide Web, and this is considered to be the World Wide Wireless Web. Okay, WWWW, 4 W's. Previously it was only 3. Okay, so now this 5G RAN system will connect everything. That means you just think about the volumes. So 1000-fold traffic volumes means what? So we can able to connect up to 100 billion wireless devices, and we are considering many types of use cases. It is not that we are using static use case. Any type of use cases. That's what I can connect with mobile. I can connect with my laptop. I can connect with my fan. Okay, so if I want to control my fan, I can use my mobile to control it. Okay, through the network, through the internet. How it is possible? Okay, that is the diversified use case. Okay, so not only we are using diversified use case, we are also maintaining the quality of service, like reliability, latency, data rate, security, privacy are all applicable to the 5G RAN, as we are going for multimedia applications. Okay, so this is what all about the 5G RAN. Now, even though it is that much sound enough in terms of technology, still we are having some kind of challenges. Okay, so this explosive growth in mobile traffic volumes will lead to some kind of other issues. Okay, so because the mobile traffic volume, see, now we are not having a single internet in our home, we are having multiple internet. So that means we are using some 3 mobile phones, means 3 internet connectivities are there, 3 types of internet connectivities are there. So in our home itself, normally casually we are using 4 internet facility or 4 internet subscribers. So now just think about the traffic value. Okay, so now massive connected devices and as I told you, diversified use cases. So now we can connect any device through the internet, means what? The use cases are also different. We are using IoT applications, we are using machine learning application, we are using mobile application, sensor applications. So these kind of use cases are all becoming a challenge to the 5G RAN. And we are also having some kind of technology to just think about these challenges to be mitigated to resolve it. Like we are having multi-tier communication, MIMOs, okay, wave backhauling. So initially the backhauling is very difficult in terms of multiple networks, but now we are having the facility of wave backhauling and extreme densification of nodes. Densification of nodes in the sense means, suppose if you are traveling in a train, okay, so if you are going into a particular remote location, if the train is moving on to the remote location, there also you can get the network connection. Previously it was not there. You will so even now you will be missing the signals, okay, and you will be saying the signal is lost. But this kind of facility will make you wherever you go, you can able to connect through the internet. So full duplex communication, it was already there. And energy harvesting technology, this is another important technology. That means we can able to save energy consumption. Okay, so these are all the some of the features what we have to think about. And you can see this diagram. From this diagram you can understand about the challenges, features, technologies and applications of 5G as a whole. Okay, so at this point I will be taking some 2 to 3 minutes break. Okay, so you just have some refreshment. My now is time is 11 to I'll be just coming back at 11:05. Okay, but please don't need not want to go outside. That means you need not want to come out of the particular Zoom meeting. Okay, you shall be here, and I'll be taking some 3 minutes break. Thank you.
Prakash sir, am I audible, sir? Prakash sir?
Yeah. Now
Yeah,
I could able to unmute.
yeah. Now
Okay.
you can do, sir. No problem, sir.
Yeah, I will share the screen.
Okay, sir. Thank you.
So now whether the screen is visible?
Yes, sir. Yes.
Okay, fine. See, until now, the first part I had discussed about the radio access networks, okay, the types of radio access networks, and especially we had seen the various generation of radio access networks. Okay, so what is 2G RAN or 3G RAN or 4G EUTRON, and why we are going for 5G RAN? Okay, so what are all the particular technologies we are just having in the 5G RAN? All this stuff we have discussed until now. So in the rest of the part of discussion, we are moving on to the security, because this is the core topic what we have to see. Okay, so just a minute. Okay, so now coming to the security in the radio access network, obviously we had seen some of the limitations of 2G and 3G. So based on that itself, we can understand there are, sorry, not there may be, there are security vulnerabilities and threats effectively happening in the 2G and 3G. Okay, so that is what we can see here also from the slides. Attacks on the 2G RAN could easily happen. Okay, because that is the situation what was happened in the previous era. So there are various loopholes, various security gaps, okay, so which is present in the 2G as well as in 3G. So there is no specific guard against eavesdropping. So I told you the term called as eavesdropping. So eavesdropping means what? Whatever conversation that we are having with our friend or official communication, official talk, everything has been monitored. Okay, so this is the situation what happened in the earlier 2G network. Okay, between the mobile and the base station, we if you are doing any communication, any voice call, everything is eavesdropped. There is no security at all. Okay, so and this kind of attack, what happened in 2G is especially the false base station attack. That means you are just thinking about you are connecting to a particular base station which is authenticated, but actually the base station itself is not a particular original base station or authenticated base station. It itself is considered to be a fake base station. Okay, so this was possible in the 2G network, and that is what the security vulnerability there. Coming to the 3G, okay, so in 3G to some extent we had provided some of the security measures, like we could able to overcome the eavesdropping. At the time of 3G we just use the encryption mechanism, so that we are using some kind of algorithms, some kind of techniques where we are using the keys, cipher keys, because as probably you might know that most of the encryption algorithms are using the key. Okay, so to encrypt the data and also for decrypting it. So this security lies only in the key, not on the algorithm. So if the key is stolen, if the key is revealed, then whatever may be the strength of the algorithm, the data is lost. The data is known to the attacker. Okay, so this is what happened in the case of the third generation network, where we could able to protect our RAN by means of using some encryption mechanism with the keys. And yeah, there is also a kind of replay attack. So the replay attack in the sense means the same data has been transferred repeatedly to the server, so that the server could not able to respond to the other persons or other activities. So this also happened in the 2G network, which has been mitigated in the third generation. That means we are using some kind of non-repeating random values. Okay. So for example, if you are sending some IP packet to a particular server, so that IP packet has been received and it has been looked by the server. For example, what this attacker will do, they will send some fake IP packets, so that the server cannot able to concentrate on the other people. That means the fake IP packets has been sent again and again, frequently, repeatedly or replayed. So now what happens, constantly this server has to look on to this particular IP packets, what it is, what is the content, and the process of just looking to the IP packets itself will take many time. So it will be processing only those IP packets. So what happened, if you want to overcome this problem, you have to just send the IP packets with some sequence values. It's not sequence value, non-repeating random values. So these random values will be just added with the IP packets, and if it has been sent again, if the same IP packet has been sent again, immediately the server could be able to understand this is an attack. Why? Because previously the same packet was received with a particular random number. Now we are having the packet with another random number. So now the server could easily respond, okay, this is a fake packet. Otherwise, if there is no random value, if the only the IP packet is coming from the authenticated source, the server has to respond it. It cannot deny it because it is coming from the authenticated source. That is the way how the server will think, but not actually it is coming from the authenticated source, it is coming from the attacker. So this kind of attack is also mitigated in the third generation to some extent. Then comes the another kind of measure, deletion and modification of conversations, because some of the conversations, some of the particular communication between the users are deleted or modified. Okay, so this can be overcome by means of providing the integrity keys. So again, integrity keys is a form of authentication mechanism. Okay, so this is also provided in the third generation. Then coming to the another problem is cloning of base station. That's what I told you, fake base station can be easily created by the attackers. So now what the mobile devices will do, they will try to communicate with the base station with a specific address, and this actually is not a authenticated base station. It may be some kind of fake or false base station, and the base station will receive all the data from your device. Okay, so now what happens, to overcome this problem, we have to think about authenticating the network by subscribers. Okay, so that is what we are doing now. So we are providing some kind of user credentials. If you are entering into your network through some Airtel or Jio, so it is initially asking for your security key. So you will be providing the key, and that key has been stored with the subscribers. Only if that key matches, then only you can able to do all the communication. So this also can be overcome by means of using the third generation. But the problem is not ended. Why? Because the third generation could not prevent a DOS attack. DOS attack in the sense means denial of service attack. Okay, so denial of service means what? For example, let us consider a IRCTC. Okay, so initially we had that IRCTC web application to book the train tickets, IRCTC. Okay, now we are having the mobile app. Okay, now just think about if a particular attacker is getting hold of that server and the service of that IRCTC, all other people cannot able to book the ticket because the server is responding only to that particular attacker. So the service has been denied to the public, to the common people. So this kind of attack, denial of service, is not overcome by the third generation. Okay, so what we have to do, we have to think about some kind of security measures. Okay, again we are just coming to the same problem, as if a large number of registration requests. See, they are just explaining the third generation issue, security issue. You just imagine there is a large number of registration requests which are sent via the RAN, okay, to the visiting network. So here the visiting network is any mobile station. Okay, so this mobile station cannot realize the registration request, okay, or fake, until it attempts to authenticate each request and the request fails. That means what will happen? So there will be a continuous request for registration by the attackers to the mobile subscriber. So these mobile subscribers cannot able to realize that this is fake. When it will just able to understand this problem is until it attempts to authenticate. It is trying to authenticate the request, whether the request was from the authenticated source or not. That it will try to do. Once if it tries to authenticate the request, immediately the request fails. Now what happens? Next request will be made by the attacker. Again it will try to authenticate. So this is the problem what we are facing as the denial of service in terms of RAN. Okay, so why? Because in RAN only we are using the base station. So accordingly we face this problem. Okay. So now to authenticate each request, what this mobile subscriber will do, they must fetch the authentication challenge material from the corresponding HLR. Okay, so this is what we are talking about, the home location register. Okay, so we are having some kind of HLR, VLR. Again I will be showing the terms. Home location register, VLR is visitor location register, and MSC is what we are talking about, the mobile switching center. See, now what is happening here in this case? Okay, so in order to authenticate each and every request, okay, this MSC must fetch the authenticate challenge material from this register. But what is the situation now? This mobile subscriber, they are busy in fetching the authenticated challenge material, and it could not able to just look for the genuine request. Earlier I told you there are frequent requests that has been made. So all this frequent registration request has been made by the attackers. So while this particular situation happens, this mobile center or subscriber wants to fetch the authenticate challenge material to check for this request. Okay, while it is busy in checking for each and every request that has been made, at that time if the original registration request come over in between, it was also lost. So this is what we are talking about, the denial of service in this case. So previously I told you about the denial of service in terms of commercial aspects with respect to IRCTC website. Okay, so now as we are focusing towards a RAN problem, RAN security issue, you just see how it is happening. So that RAN could not able to just concentrate on the particular genuine request itself because of that particular mobile subscriber looking for the other activity. So they are busy in fetching the authentication material to just check for the registration request. So this is the problem what we are facing with the third generation, and that is a particular attack. What we are calling as DOS attack. Now in order to overcome this, we have to go to the next network, that is what we are having as a long-term evaluation. Okay, so these LTE networks are coming recently, and it is considered to be the dominant technology in 2018, and by 2023 we will be reaching 5.5 billion subscriptions almost. Okay, so this is the boon for the next generation broadband network because it provides high performance with respect to data rates, lower latency, strong resiliency towards multipath fading, better efficiency, seamless integration with other existing non-LTE wireless networks. So these are all the particular characteristics of the LTE network. So it is providing the high performance, and it is having two important components. One is the e-utron, that is what I told you, evolved universal terrestrial radio access network, and the next one is the evolved packet core. See, this evolved packet core is what I discussed earlier. Okay, right. Now we may be considering, okay, this is fine. Okay, so this LTE network is fine, and we are supposed to overcome the problem. Okay, yes, obviously it is providing some kind of security mechanism. So how, in what way we can say this is providing the security mechanism means, if you are looking back the third generation only introduced the mutual authentication mechanism, which can be utilized by some well-known cryptographic algorithms. But on the other end, moving to the LTE, okay, it also additionally provide, okay, apart from the mutual authentication and encryption algorithms, cryptographic algorithms, it additionally strengthen this existing security measures by means of signaling protocols. Okay, so we are just encrypting and we are just authenticating not only the data, the signaling protocols also. Okay, so the entire protocol itself, the entire signaling protocols itself has been secured, has been authenticated. So previously it was just an authentication between the particular user equipment and the particular internet. But now in terms of LTE, what happens? We are just strengthening this kind of mechanisms to the next level. Okay, that means we are just providing the security mechanisms for in the signaling protocols itself. So this is the way how we are improving the security. Even though it was like that, the LTE based mobile devices are also prone to attacks. Okay, so now that means what? Even though we are moving to the LTE network, still the attacks is not completely removed. Okay, so we are having some new features with respect to LTE network, like flat IP connectivity, full internet with heterogeneous networks. Okay, but all these unique features also lead to some kind of attacks and threats which are new. So now we have to just focus on this kind of security attacks in LTE. Okay, so that can be broadly classified into two categories. One is the radio access network attacks and another one is the core network attacks. So here I am not focusing on the core network attacks, only we are just, according to the topic, we are just discussing the radio access network attacks. Okay, so coming to the radio access network attacks, so the obvious attack always we are talking about is the eavesdropping. Okay, so eavesdropping the broadcast channel information, so that the attacker could be able to know about the IMSI number. What is IMSI? Any idea? Everyone heard about IMSI? Sorry, my dear friends. International Message Subscriber Identity. Okay, so which has been provided by the subscribers. Okay, for your SIM card. For each and every SIM card, we are having this particular IMSI number. Okay, so this will be known to the attacker by means of eavesdropping and also revealing the LTE device location or radio smart jamming. So this LTE device location also has been revealed, where exactly this device is present. Okay, where our mobile phone is present, and also it will be just jamming the radio waves. Okay, so this kind of attacks are still available even though if you are using the LTE. Okay, so among these attacks, the first one is the IMSI catcher. So IMSI catcher is what trying to just capture the IMSI number. So it is a telephone eavesdropping device. Actually, it is a device which is used for intercepting our mobile traffic and tracking our location. Okay, so it was already there in the 2G itself. Okay, at that time we could not able to avoid this attack completely. So because there was no authentication at all. Okay, so this face, as I mentioned, there are fake base stations available and they are used as the IMSI catcher to track movement of attackers. So this was available right from the 2G. Okay, but now it was mitigated to some extent but not completely still. Okay, so this is one kind of attack what we have to consider. And another famous attack is the DOS, that is what I told you, the active attack. Okay, so it can be targeting the user equipment in either of these ways. The first one is it will make your 4G network to degrade to 2G or 3G. So that is one way it is attacking. The next one is it will temporarily deny to all the available networks or selectively limit the LTE device. That means what? It will deny to all the networks. Okay. Otherwise, it will selectively limit any specific LTE devices only to use some specific services. So now, so these two attacks are very much should be known according to the RAN. But apart from that, I already told you there are taxonomy of security attacks in LTE. Okay, so now you shall see. So in LTE, we are having both radio access network and core network. So that is what here in this slide it was shown. And here I am focusing only towards radio access network. Again, it has been categorized into two types. One is the vulnerabilities to privacy and another one is the vulnerability to availability. So vulnerability to privacy means we are trying to retrieve the information. Okay, retrieve the IMSI number, location. Okay, all these are coming under the privacy. So if my location is known to the attacker, that is difficult. Then coming to the another category, that is vulnerabilities to availability. So that means what, whether the radio frequency waves are jammed or not. Okay, so and also it will just provide some kind of rogue E node. So as I mentioned in the architecture, LTE architecture, we are having the E node B. Okay, so this E node B is supposed to be the particular interface which will connect the user equipment with the core network. Anyway, to recall, I will show it again. You can see the E node B. It is nothing but the base station transceiver called as E node B. This will connect your user equipment to the core network. So now that has been targeted. Okay, so that means what? Instead of the real E node B, there may be some kind of fake. Okay, so that is what rogue E node B. And another attack is DOS, Sun DDoS. That is what I already mentioned. So as a overall, if you could see the taxonomy of RAN attacks, the most two important attacks are IMSI catching and DOS, or distributed denial of service. So again, under the DDoS, we can have some three different subcategories. So one is the botnet launched DDoS, another one is denying all network services. That is what I told you. So all the available networks are denied. Okay, and soft downgrade to GSM. So now I am using 5G network or 4G network. Because of this attack, it will be degraded to 2G. That is also there. So this is the overall taxonomy of the RAN attack exclusively, you can see. So coming to this category, vulnerability to privacy, that is attack against privacy. So the IMSI, already I mentioned about the IMSI. The idea here is, or we are not just doing any kind of transfer or communicating this IMSI. Okay, because commercially speaking, we are not doing this kind of communicating this IMSI number. So that is the reason why we are almost secure. Okay, if you are using the 4G or 5G. But there is one situation where we have to communicate this IMSI number. Okay, so that is what the problem rise. So for the sake of user privacy and confidentiality, we are not doing this kind of transmission frequently, but it is necessary to have this communication at least once during the radio communication. Okay, so here when we are doing that communication is, suppose at the first instance, that means at first time if you are switching your mobile to connect to the network, from that mobile the particular network can be established with authentication through this IMSI only. Okay, this is the situation. So at the first instance of switching your mobile to connect to the network, the mobile has to authenticate, or the network has to authenticate the mobile phone. At that time only we are just making use of this through the IMSI. So that is monitored, eavesdropped by the attacker. Why it is monitored and eavesdropped? Because this authentication process of IMSI is done by means of without any kind of authentication and encryption that has been really happening. That means what? You are doing the task at the first instance. So at the first instance, if you are trying to connect with the network, what happened? The IMSI is transmitted from the network to the particular mobile by means of direct communication. That is, before the actual security mechanism, it is happening. There this IMSI catcher will come into play. They will exploit the network. Okay, so this is the problem. Okay, if you are thinking more details about further attack, still we can make use of this rogue E0B, as I mentioned. That is also there. We can able to set up the rogue or fake E0B that will impersonate your real network, and it can able to simply command each mobile device. Okay, so this cannot be done by an individual people, whereas IMSI catcher can be done by individual person. So you have to worry about IMSI catcher, but you need not worry about rogue E0B. But this will be happen by a particular organization. For example, if any other country wants to hack our mobile phone, wants to collect the data from our mobile phone, then the organization, the country themselves will able to create such kind of rogue E0. So any individual cannot do it. That is not possible because it is costly to perform this attack also. Okay, so this is the problem regarding the attack against privacy. Okay, let us see how this IMSI catcher is functioning, working. So you can see the details. Mobile phones, generally what it will do, it will be looking for some kind of mobile tower with the strongest signal in order to get the best communication. So normally where the strongest signal will occur, if there is a mobile tower nearby. At the same time that when a device connects to a cell tower, so if it is finding a nearest tower, the device immediately try to connect to the cell tower which is nearby. For that it has to authenticate. That's what I told you. So for that authentication only we are using the IMSI. Here only the mobile phone has to authenticate the cell phone tower, whereas the cell phone tower need not want to authenticate back. This is the situation. So this is why every time someone places a device that acts as a cell tower near your phone, it would connect to it and give away its IMSI. Okay, so this is the situation. So yes, the cell phone tower did not want to authenticate back. In the sense means what? Anyone can set up a fake base station like this, or anyone can have this particular IMSI device in between, and what it will do, it will provide some kind of strongest signal to the mobile phone, and the mobile phone will authenticate through the device. Okay, so this is the situation. What I am trying to mean is, see, if I am placing some kind of device, okay, nearer to your mobile phone, you are having your mobile phone, you are trying to connect to your network. So you are searching for the strongest signal nearby. Okay, that means you are searching for the cell tower. What I am doing is I am placing a IMSI device between the cell phone tower and your mobile. Now what happens, because of having this device functionality, okay, the weaker signal earlier which was happened now becomes stronger. How it is stronger? Because of the IMSI device, catcher device what I am having. So now what happens, the mobile phone will track, okay, now we are getting the signal, okay, we can authenticate. Like that it is trying to provide the details. Okay, so this disclosure of these details of IMSI can compromise the user information, location information, and also the conversation. Okay, so this is the problem of attack, IMSI catcher. Coming to the location tracking, this is another kind of attack what we have to see under this category. So there are two categories, one is IMSI catching and another one is location tracking. Okay, so the location tracking, the normally what your user location is considered to be a private information. Okay, for any kind of uninterrupted services, our modern standards permit this mobile subscriber to collect the physical locations of the mobile user. It is not put on you, this problem, okay, this attack. Why this is not put on you is, it is the part of the mobile subscriber. They will try to collect the physical locations. Okay, so due to some reasons for uninterrupted services, okay, they want to know the physical location of the mobile server, then only they can provide the services without any weak signal. Okay, now what happens, this is the situation where the attacker comes into role. So the recent advanced in positioning technologies, okay, and location based services will make the attacker to know or will impose a threat on this privacy and location confidentiality. So while the particular subscriber is trying to just to find out the physical locations for uninterrupted services, at that period, okay, this particular attacker also will try to track the location and it can able to just perform some attack on it. Actually this is what we are seeing from the diagram. Passive attacks, this kind of attack we shall represent as passive attack because it is not in your hands. Okay, it is actually attacking the subscriber interception. Okay, so if the subscriber is not properly doing the task, it will be considered as an attack. Okay, okay, now what these passive attacks can do again is, they can able to retrieve this IMSI as usual to decide whether the target user is present in that area, because this is actually a location tracking. In order to perform the location tracking, that IMSI is also revealed to the attacker. Okay, because already we know about the IMSI catcher. Okay, so using that technology, they can able to find out the particular user's location also. So now what happened, we are having this particular situation based on this, like we are having the cell random network temporary identifier, which is a physical layer identifier uniquely defined per device within a given cell. So the idea is, what the subscriber will provide to the mobile phones is, they will be providing a CRNTA, that is the cell random network temporary identifier. Okay, using this identifier only, the particular mobile subscribers or the stations could be able to just find out your location and asking your data. So that is what it is happening in the diagram. It is asking for, it is requesting the CRNTI Once if it is granted means what? That using that particular RNTI, that is random network temporary identifier. Okay, so the attacker could able to track that, and they can able to perform some kind of attack on it. Okay, so this is what we are talking about, the location tracking. Then comes the another type kind of attack called as attack against availability. So this is another taxonomy of security attack on RAN. So one is the RF and low power smart jamming. So here this kind of attacks is happening in the physical layer to make the network appear unresponsive. Okay, so that the network will not be known. Okay, because it is attacking the physical layer. So due to this reason, the RAN itself is not available for many user equipment. That means these radio frequency jammers will deliberately just avoid the radio communication, okay, to happen between the base station and the user equipment. So what it will do is it will just decrease the SNR of the received signal without raising any alerts. Okay, so it will not provide any alert, just it will deny the service. That means it will deny the service of the particular device, the RAN, for any user equipment. So user equipment could not able to connect to the internet or any core network because the RAN is not available. Okay, so but this is not present in LTE network, so we need not want to worry about this kind of attack at present. Then comes the smart jammer. In this case, what is happen is it is performed by saturating one or more of the control channels in both downlink and uplink. Okay, so that means radio frequency jammers is not happening in the present network, so fine. But the smart jammer is still there. This kind of attack is still available. So it is performed by saturating one or more of the control channels in both downlink and uplink. Okay, that means for example, you just imagine if you are trying to download some data in your mobile with internet facility, what is the bandwidth you are getting? Similarly, you just check if you are uploading some data from your mobile to another network, what bandwidth it takes. That means you just check for the particular data rate. Okay, so both data rate normally differs, because downloading normally it will be very quick, but for uploading it will take some time. So that everyone knows it. What the smart jammer will do, it will saturate. Okay, so it will saturate one or more of the control signals in both downlink as well as uplink, and it will target narrower control channel, leading to less power consumption. Okay, so this is the problem. So it will just saturate the entire channel in both cases, both downlink and uplink. And what happened, due to this reason, the attacker will target narrowing down the control channels for less power consumption. So the idea is what, if you are downloading something means it will take some more power supply, and for uploading it will take an additional power supply, that we know. Okay, so now what happens, it will control all this entire channel, means what, it will make your system to consume less power. Okay, so due to this reason, it would deny the mobile services to all the user equipment within the target cell. So now what happens, this particular base station cannot able to provide the respective services because of the less power consumption which is happening in the entire control channel. Okay, now coming to the next attack is the rogue base station. Already I mentioned it. Okay, but anyway, so now what the attacker can do is he can purchase a personal E node B, okay, or even he could able to compromise a commercial base station by means of botnet attack or physical penetration, something they can able to launch. Okay, So these attacks are normally what it can do is it can send certain tracking area update reject messages. That means this e-node B is supposed to track the location of the particular user equipment. Okay, so while this is happening, this attacker will send some kind of messages to reject this kind of tracking area. Okay, so because of this, what happens, the particular user equipment cannot be tracked with the respective network. Okay, and hence the user equipment will be downgraded to the non-LTE network, or it may be delayed or denied for the mobile services. So this is what this particular e-node B will be doing. So it could able to just send some kind of reject messages, okay, using this particular e-node B, so that user equipment will be downgraded. Okay, so this is what we are talking about, the road base station. Then comes the another form of attack called as botnet launched DDoS attack. So here it is not done again by the individual case. So any country can able to create some kind of bot masters. Okay, so all this bot master will have different botnet nodes. At the same time, they will be launching and sending to various servers of different countries. Okay, so that means what, it will be targeting a huge organization instead of a single node or single network. It will be targeting the bulk node or bulk network, big network. Okay, so because of this, what happened, as it is targeting in multiples, we are having some kind of congestions during the downlink or the uplink. So due to this congestion, we cannot able to just do our regular task. Okay, so that means we are having a flood of attach and detach messages, and this flooding attacks will create some kind of disruption in the particular regular task or regular communication, which will be overall affected, and due to that we are not able to provide the respective services. Okay, the services are denied because of this flooding attack, okay, from the botnet. So this flooding attack will flood all such kind of machines or the user equipments. Not only the user equipments, the web servers, okay, the control servers, all this has been affected as a whole. So this is also a kind of attack which is happening in the RAN. So the entire network, RAN network, has been occupied by some other task. Okay, so this is the problem what we are having with the botnet launched DDoS attack. So these are all some of the attacks. See, all these attacks are recent attacks that we have to know. Okay, so this is what I want to share with you. We have to just understand about these attacks. So if we want to further explore each and every attack, it is a separate task which we have to work more on this. Okay, but anyway, we have to know about some kind of attacks like this. That is the reason why I had shared about such kind of attacks to you, because all these particular details I have been collecting from the recent 5 years only. Okay, normally you can see all this kind of attacks has been recently evolved because of this fifth generation networks. So this kind of attacks, first we have to understand. Once if we understand these attacks, then we have to find out a security mechanism to overcome this. So why I am talking about this attack means, if you are doing research in 5G networks, definitely you would be thinking about the security gaps. So how to just overcome this kind of attacks? So this is a new kind of research which you can explore further. Okay, so that means what? This attacks will be existing for another 10 years by default. Okay, so finding some solution for this attack, or providing some kind of security measures to overcome this attack, will definitely a particular research domain. so which you can work on it for another 3 to 4 years, so that you can easily finish off with some ideas or some kind of methodologies that can be implemented. Okay, so that is the reason why I'm just making you aware about these attacks, that's all. Okay, so otherwise if we want to explore, if we want to go in depth, we have to deep dive into it, so that will be taking more time. So that just making you understand about these attacks will help you to just explore, okay, I can go in this particular domain, so and try to find out some kind of mechanisms or measures to overcome these attacks. Okay, so that will be a major research area for you. Okay, so with this I am concluding the session.
Thank you, sir, for a wonderful presentation.
Okay,
Participants, if you have any queries, please put it in the chat box or just unmute yourself and ask the questions. Participants, if you have any queries, please put it in the chat box or just unmute yourself and ask the questions.
otherwise you shall contact through my mail id, so that I can just provide more inputs. Okay, just a minute, I will share it. This is my mail id. If you are having any doubts related to security, see, my dear friends, I am not that much familiar with the wireless networks, because my domain is especially on security, a threat and its countermeasures. Okay, so that's what I am narrowing down to this topic. So what is all about the security threat? How it functions? What is the characteristics? So what is the way to overcome this attack? So like that I can support you. But if you are asking about some kind of details, yeah, some question was here. Just a minute. Sorry, where is that? Just now I saw it.
Yes, sir. One question
I
is asked from Mr. Kannan Subramaniam that what is the
ah
simulator to research in this area?
yeah, simulator in the sense means with respect to security, there is no simulator so far. Okay, so generally you can use Wireshark. Wireshark is the particular simulator where we can able to track the IP packets. That is one simulator what we can do. But especially for this radio access network, we are not having any simulators that is functionable. Okay. Otherwise, we can just think about Wireshark for this IP packet tracking everything. And NS3 is there, obviously network simulator, NS3 simulators are there. So these two simulators will function. And also you can see Nessus, NESSUS, but these are all not related to the RAM, radio access network. That's what I am saying. This is a explorable research area or domain. Okay, so no specific simulators to overcome these attacks are found so far. Okay, so if you are trying to just do some research, you can also develop some kind of a model or simulation technique which will help you as well as for the community.
Thank you, sir.
Thank you.
Participants, if you have any other questions, please ask.
So I had given my mail ID also. You shall contact through that mail ID. Okay.
Yes, sir.
So that's all from myself. So on behalf of myself and my institution, I just thank the organizers of this effective STTP program on fifth generation wireless networks. Okay, for providing a platform between you and us. Okay, so this will be helping me also to explore more on this kind of newer domain especially. Okay, so I thank everyone, participants, organizers, management of Kongunadu College of Engineering, okay, for the uh, lecture. Thank you.
Thank you very much, sir.
Okay, thank you, thank you. Shall I leave?
Yes, sir.
Thank you.
And I also like to thank all the participants who helped us to complete the day 4 session 1 of STTP successfully. And participants, the day 4 session 1 attendance cum feedback link is provided in the chat box. Do fill it. Thank you.